Assalamualaikum and salam sejahtera. We meet again. So today we're going to learn about the equilibrium in the 2D pulley system. This is the situation. We have a block of mass A hang using 6 pulleys and a cable wrapped along all the pulleys. So of this configuration, we can have a very small T to hold the mass at this position. As long as the thing is stationary like this, we call it a static equilibrium. So given that the mass of each pulley, all the pulley here, is negligible, and the friction between the cable and the pulley also negligible, I mean it's equal to 0. So to solve this one, of course, we are to find the T, and of course the number one thing you have to do is you must be able to draw the FBD correctly. So how to do it? So how to solve it? You have to draw FBD at all 6 pulleys. Let's say if I name it, this is the pulley A, pulley B, pulley C, pulley D, pulley E, and pulley F. And we have one cable on the pulley D. Always start at the pulley that we know the value or the value that we want to determine. So we start at the pulley D, having tension T. So this is the pulley D. You know the tension to be determined. The T, and then because the cable is wrapped on this pulley D, so the tension here, this here also is the same here. So this is also T. So and then the cable here goes to the bottom here on the pulley A here, this A, and this is B, this is C. So the same cable, so the tension has to be opposite of the one. And then the same cable also wrapped here. Let me do this one here. Cable wrapped along, and then it goes to this point here. So it is this is the T, this is the T. So the thing that connected to the pulley here is also T. So knowing the equilibrium equation, summation of force Y is equal to 0, FBD D here. So, and then of course this reaction here, the tension here, 1, 2, 3. So it is a 3T. And then you go to the pulley E. Pulley E. So this is the 3T. This is 3T now. So the pulley here is 3T. And wrapped along here also 3T. And the same cable here goes down to the pulley B here. So the same cable, so the pulley B having the 3T, and then the same cable wrapped on the pulley B goes here, same cable here having the 3T, and the same cable go here, and then the cable here also having the 3T. So again, summation of force Y is 0, so this cable here we know it is the 9T, 3 plus 3 plus T. Then we go to the pulley F. We draw the pulley F here. I have to be a bit far away from the alignment. So the pulley F. So this is 9T. This is 9T. So 9T goes to here. So this is the 9T. And then the cable here. Same cable. You got the 9T. And then this cable goes to the pulley C here. So pulley C having the 9T, and the same cable is the 9T connected to here. This cable here connected the center, this one connected this here to the 9T, and of course the reaction here is 27T. Okay, now we have got this on this diagram. So we know this is the mass here as MA. For the weight is time G. So for this FBD, So summation of force Y is equal to 0. Okay, we got the 9 plus 9 is 18 T positive, plus 3 is equal plus 6 T, plus 1 plus 1 2 T. The mass here is downward, minus MAG is equal to 0. Then we get the MAG is equal to 26 T. Then we get the MA is equal to 26 T over G. So if you are given that the mass, let's say whatever given, if given the mass is equal to 100 kilogram, then we got that T is equal to 100 divided by 100 times 9.81 divided by 26. That means the T here, the amount of force you put here is 1 over 26 of the mass here. That's why we use a pulley, because we use a pulley rep many times. So you just need a very minimal force to lift heavy weight of material. This is a different scenario. We have 4 pulley here, 1 mass hanging on the left. So we have 1 cable wrapped on the 2 pulley, another cable wrapped on this pulley, another cable wrapped on this pulley. Given that the mass of each pulley is M, but again the friction between the pulley and the cable is 0. Now we have to start to draw the FBD. Again, always start the FBD at the end point of the system. So always start this pulley here. Let's say I call it as this is a pulley A, pulley B, pulley C, and pulley D. We start the pulley A. Pulley A, we have the tension, same thing tension here because the same cable. But again, don't forget, given that the mass of the pulley is there, so the pulley having a mass M, G. And of course, here is the reaction, here is whatever, just put a reaction, because we don't bother about determining the reaction, we just need to know what the T. And if given the mass, let's say given the mass, say 100 kilogram, we have to determine how much T to put to maintain the equilibrium. So the pulley A done. Now pulley B. Pulley B, we have the tension here. So if it has T and then wrap along this one, it is T. But again, don't forget, you got the mass mg. Yeah. So, and then what is the tension here? Summation of force Y is equal to 0. Then you get the T plus T minus mg minus whatever they call it. Let's say reaction 2. Reaction 2 is equal to 0. Then you get that reaction 2 is equal to 2T minus mg. So here is, let me change it straight away. 2T minus mg. Okay, this is the pulley B. Now you go to pulley C. When you draw the pulley C, the cable that go to pulley C is cable of this one. So it is the 2T minus mg. Same thing goes here. 2T minus mg. And the pulley also get the mass. The mg. Mass always downward, yeah? And also now you got the reaction 3. Reaction 3 is what? Again, do the summation of cos y is equal to 0. Then you get the 2 times 2t minus mg minus mg this one. This one is, we got 2 of this. This one minus R3 is equal to 0. Then we got the R3 is equal to, I need to calculate, 40 minus 3 mg. Yeah? Okay. Now we go to the pulley D. This is C. Go to the pulley D. Then you got here is the 40 minus 3 mg. Same cable goes here. 40 minus 3 mg. You got the mass itself, mg. And also now we got the, here is the MAG, the mass of the block. Yeah, this is the pulley D. We do summation of the force of the ABD here is equal to 0. Then you got the 2 times 40 minus 3 mg, because we got 2 here, minus mg, the mass of the pulley, minus MAG is equal to 0. So from this equation, then you can go to determine that MAG is equal to 80 minus 7 mg. So from here you can determine that T is equal to MA minus 7m of times G over 8. Sorry about this messy thing. So this is your answer. Okay? Thank you very much for listening. I hope this pulley system, you can understand them well. Try yourself afterward. You just simply sketch the pulley and then try yourself, and I'll look back into this video, see how well you understand the concept. These two pulley systems, I have used them in the previous many years exam. I would say, although I have shown in the class, about only 40% can answer them correct in the exam. So I want you to practice them again, just in case if this question appear again in the exam, you won't be disappointed. Thank you. See you again in next video.